In this specific case, we are given a side, an angle, and a side. In the case of side, angle, side, or side, 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 we use the law of cosine, which states that c squared equals a squared plus b squared minus 2ab cosine c, because in this case we are not given c right here, which is directly across it. So how we would write this is, so this one we identify as side, angle, side. So we are going to use the law of cosine, which in this case would be c squared equals a squared plus b squared minus 2ab, which are the two sides that correlate with these, cosine c. Because we're looking for c, the cosine relates to that over there. So we're just going to plug and chug. So a here is 5, b is 8, and then angle c is 40 degrees. So we go ahead and we do c squared equals a squared plus b squared minus 2 times a times b, and we have cosine of 40 degrees. So doing this on the calculator, it will just be 5 squared plus 8 squared, and I set that, and then 2 times 5 times 8 times cosine of 40, and I get that. So then what I do is I take this and I subtract it from this, and we get 27. So right here we get 27.716. Now that we get this whole part, we have to square root it to get c, and then we do square root of 27. So now we just press second square root and then of the answer, and we get 5.26. So our c will be 5.26. So this right here is 5.26. So now we're going to solve for this angle A. To solve for angle A, now that we have this side, we can use the law of sine, which now what we do is we look directly across A. So we know it's a 5. So it is sine of A, and we set that equal to that new side that we got, and that is over sine of 40 degrees because it's already given. So we do cross multiplication, and we'll see that sine of A will just be 5 times sine of 40 divided by 5.26. So 5 sine 40 divided by 5.26, and we'll get sine A equals. So now we are going to go ahead and do that. So I will do 5 times sine 40, enter, divided by 5.26, and we get 0.611. So 0.611. And now to get A by itself, we do inverse sine of 0.611. So right here, we just go second inverse sine of the answer, and we get 37.66 degrees. So this right here is 37.66 degrees. And now it's really easy to find B because we know that angle A plus B plus C must equal 180 degrees. We already know A, we already know C. So this is going to be really easy. You just subtract. So 40 plus the answer, and then you do 180 minus that. And we see that our B angle here is going to be 102.34 degrees. So in this next triangle, we determine what kind of triangle it is. Obviously, it's an oblique triangle with different angles, but what is the information that is given to us? So in this specific problem, we're given an angle with a side, so we determine it as a angle side, and in this case we use the law of sine. If it was also angle side angle, we use the law of sine. So what we go ahead and do is first we need to set it up. So how do we set this up? We see that we're given 8, and it is across sine of 100 degrees, and then we need A and B, that's the side, and it is across this angle. So that angle is actually 180 degrees minus 100 minus 45, and then you'll see that that angle is actually just going to be 35 degrees. So here will be sine 35. Now to find AB, it is just this multiplied by this divided by this. If you cross multiply and you isolate AB, that's how you do it. So it would just be 8 sine 35 divided by sine of 100. And then we go ahead and we punch that into the calculator. Divided by sine of 100, and we see that that side is actually going to be 4.66 centimeters. So now we have that one. So for the law of sine, anytime you see a triangle that is ASA or AAS, in the case that you see SSA, which is the ambiguous case, what that means is no triangle exists with the given information. One triangle exists or two distinct triangles exist, but I don't think they're going to give you the ambiguous case. They will give you the law of sine or the law of cosine. And then the law of cosine states that when you see a triangle in the case of SAS or side, you can use the law of cosine, which is in the format. So depending on what you're given, it is this formula for every single one. You're just moving this. So in this case, since we were finding this one, the one right across C, you put C on the outside. If you're not given this side, then you do A squared, which would be B squared plus C squared minus 2BC cosine of A. So you just move this formula around to do a side or side angle side for that. So in this next problem, you are going to see imaginary number I. So in this case, remember that I is I to the first power, which is just the square root of -1, because it has both positive and negative. So it has to be square root, and I to the second power will be -1, because when you put a square and you put it on the other side, it cancels out the square root. So you're just left with the -1. Now, this problem right here, what you do is you just write it as 1 minus I, 1 minus I, 1 plus I. You do the distributive property, so you take everything out, you'll see it's 1 minus 2I plus I squared, and then here it's 1 plus 2I plus I squared. You'll see that the 1's divide out, the I squares divide out, so you're just left with a negative and positive. 2I and 2I, you reduce the 2's, so you'll be left with minus I over I, which when you divide out the i's, you're just left with a negative 1. Now for a problem like this, the 2's just divide out. There's 2 to the power of 2 on top and to the bottom, so you are just left with I. So if you see answers, you can, if you see an answer as I or square root of negative 1, those would be the correct answer. So in this problem, we're given complex numbers a and b, and we are asked to divide them. So what we do is we write it out. Now doing this by hand, to divide this, what you want to do is you want to rationalize the denominator. What that just means is multiply the top and bottom by the bottom's complex conjugate. So then what this would be is 10 plus j3 times minus 6 minus j4 divided by minus 6 plus j4 times minus 6 minus j4. And now we just solve for that, and it would be negative 60 minus 40j minus 18j minus 12j squared, and then you have 36 plus 24j minus 24j minus 16j squared. Now we know that j squared is just a negative 1. So when we plug it in here and here, we just get, since it's already negative, we get positive 12, and over here we get positive 16. This part cancels out, so on the top we have minus 60 minus j 58 plus 12 over 36 plus 16, which we just get minus 48 minus j 58 over 52. Now this part's easy, you can just do in the calculator. You divide this by this and you divide this by this, ignoring the j. So how we are going to do that is, as I say here, so you do minus 48 divided by 52, you get negative 0.923, and then you go ahead and you do 58 divided by 52, and you add the negative, so negative 58 divided by 52, and you get negative, so you do minus, and then now you add the j, 1.15. That's how you get the answer. For this problem over here, we're going to multiply. Multiplication is a lot easier because in this case we are just going to use the distributive property. So multiply this by this, minus 60 plus 40j minus 18j plus 12j squared. All you know that j squared is minus 1, so this becomes minus 12. So it's minus 60 minus 12, and then you subtract this from this, and it's 22j. So then your final answer becomes minus 72 plus 22j. Now, if you want to do this in polar form, it's actually, you can also do it through the calculator as well. So what you would do is first you convert A into polar. So we have A, we have 10 is the X and the 3 is the Y. So what you do is you press second angle, you scroll over to the right, and the first option says rectangular to polar, and you're looking for the R value. And then the second option says rectangular to polar, and you're looking for the angle. So first we're going to find the R value. So we go ahead and put 10, second, and then you put comma, and then you put just 3, you close it, and that is your R value. So we have 10.44. Now we are going to do that again, but this time we're going to choose the second option to find. So we're going to put 10 again, comma, 3, and that's our angle. So this angle 16.7 degrees. We do the same for B, first one. So we have a -6, comma, and a 4. So we have 7.211 angle. And then we go ahead and we move to the second option. So we put in -6, comma, 4 again. And we have 146.31 degrees. When you do this and you're dividing, so when you're dividing this with division, how it works with polar is this gets divided by this, but then this top is subtracted from this one. So when you do 10.44 divided by 7.211, you get 1.448. Then angle, so you do 16.7 minus 146.31, you get minus 129.61 degrees. And now you have to convert this back into rectangular. So you go second angle. Now you're going to do polar to rectangular to find your X value. So you're going to put just this 1.448, comma, and then you put 129.61. And that gets you your X value minus 0.923. Then you go ahead and you do the same. This time you choose the Y value and you put the same 448, comma, 129.61. There you go. J115. But we know that we didn't put the negative sign, so over here it's just minus. That's how you do it through the calculator, converting it from rectangular to polar, and then you can do the same for this one. So let's say you're given 3 line equations and you are asked to find the vertices. Now the vertices is the point of intersection between these 3 equations. So each equation, you solve it for y. So let's first label each one. 1, 2, 3. So this one, if you get y by itself, you'll see that y is equal to -2x. This one, you'll see that if you move the y to the other side, you'll get y equals x. And this one, when you move the y to the other side, you'll have y equals 2x minus 3. Now you've put this in the form as you remember y equals mx plus b. Your b is in the y direction, and your m is your slope. So that's the form we have it. So the first thing we need to do is we need to find the vertices. The vertices, like I said, point of intersection. So what you want to do is you want to solve from equation 1 to 2, from 2 to 3, and the only one that's left is from 1 to 3. So when you solve these equations, so this is how we're going to go ahead and do it first. So as we can see, y is negative 2x, and it's with 2, so y equals x. So we just plug in an x where the y is. So it would be x equals negative 2x. You divide out the negative, you subtract. So it would be 0 equals negative 3x divided by negative 3, and you get x equals 0. Once you have x equals 0, then you plug in this value into this equation because 1, 1. So then you would just get y equals negative 2 times 0. So then you get y equals 0. So your value, your first intersection point is going to be 0 for x, 0 for y. Now you do 2 and 3. So you have 2 and you have equation 3. You plug in x for y over here. So you get x equals 2x minus 3, subtract it. So it'll actually be a x minus 3, add 3 equals x. So you get a 3 there. And then now you plug this into 3. So then you get y equals 2 times 3 minus 3. You get 6 minus 3. So your y is 3. So we have 3, 3. Now for this last one, since you're going to have two variables, the best thing to do is set both of them, add them together and set them equal to 0. So what you do there, you add this back there. So you would have a positive y plus 2x, which would equal to 0. And you do this one, positive y minus 2x plus 3, set that equal to 0. The 2x's cancel out, the 2y's add together, plus 3 equals 0, subtract it, negative 3, divide by 2, and you have y equals negative 3/2. Now you can use this, you plug it into either one. So let's say we have this one. Let's do it to that one since it's easier. So we just go negative 3/2 equals negative 2x, divide by negative 2, divide by negative 2, and you'll get x equals 3/4. So in this one, our vertices point of intersection is this. So now let's say you're given an equation like this and it asks you to find the point of inflection on this function right here. Now, if you review back, you'll know that the point of inflection is where a curve changes its slope. So from a concave upward, it goes to concave downward or vice versa. So a concave upward, the slope increases. So if you were to do the tangent, and the tangent there, that's a slope increase. So that would be concave upward. Concave downward would be the opposite of that, where there's a slope change. So then that is a concave downward and the slope decreases. Now, if you also remember, the derivative is used for a function like this to give us the slope. So the first derivative would do that. And the second derivative tells us if the slope is increasing or decreasing, which is what we need to find the point of inflection in this certain curve equation. So what we are going to do, we are going to set our function y equals 3x cubed plus x squared minus 5x. We are going to take the first derivative. So y equals the first derivative, you just multiply the power by the coefficient. So that's just 9, and then the power reduces by 1 plus bring the power, so it's 2x, and then this, since there's just a power of 1, it would be minus 1. So we've just taken the first derivative. Now this would tell us, so this will give us the slope. Now we take the second derivative and it will tell us whether the slope is increasing or decreasing. So we go ahead and we take the second derivative. So now you do the same step again and you reduce one power. This is 2. So we look at this, and now we just solve for x, which is fairly easy. So we go ahead and we set y equal to 0. So 18x plus 2, negative 2 equals 18x divided by 18. We'll see that x equals negative 1/9. So we have 1/9. And then what this tells us is that f of x is concave downward up to the point x equals negative 1/9, and then it is concave upward from x equals negative 1/9 and so forth. So given this function equals 3x squared plus 2xy minus y squared, you are to differentiate f with respect to y. Now this is really easy. You see the different terms right here? So this is how you do it. You set this up as differentiate f. So for the first part, it's 3x squared with respect to y plus differentiate 2xy with respect to y, because that's what it asks us, and then y squared with respect to y. So differentiating 3x squared with respect to y, there is no y in this right here, so it's just 0. Differentiating this with respect to y, the derivative of y is just going to be 1. So 1 would be multiplied by 2x. You're left with 2x. Here's a minus, so you're differentiating y squared with respect to y. So you take the derivative, it would just be 2y, and the power gets reduced by 1. It's 2y. And now your final answer is just 2x minus 2y. So you're given a second order system and it's asking how to describe this system. So the answer they're looking for is whether the system is underdamped, overdamped, or critically damped. So the first step into solving this differential equation is first you're going to set up the characteristic equation, which you just look at the powers, and it's just d squared plus 8d plus 16 equals to 0. So that's your differential equation, characteristic equation, which you would have seen a lot during your control system when you are looking for overdamp, underdamp, and whatnot. So you see that this is a second order system, and so where you would look in your reference book if you were to try to find this equation to determine what kind of system it is, in my reference book, it's on page 36, and this is a second order linear homogeneous differential equation with constant coefficients. And how they set it up is like this. So AR plus B equals 0. And here you compare coefficients of A and B. So our A in this is an 8. Our A squared is 8 times 8, 64. Our B is 16. And our 4B is 64. Here what we do is we compare A squared with 4B, And since they are equal, our system is critically damped. Now, in the case that a squared was less than 4b, the system is underdamped. And in the case that a squared is greater than 4b, it is overdamped. This is really easy to remember because less than, under, greater than, over. And that's how you solve this problem. Now, here it's asking you to find the general solution, which is a format, a general format which this second order system is set up in. So you can find this in the reference in the same section as the previous problem. And the general solutions would be if a squared is greater than 4b, then y equals c1 e r1x plus c2 e r2x for that case where it is overdamped. Now for a case where it is critically damped, the equation is y equals c1 plus c2x e r1x. And in the case where a2 is less than 4b, which is underdamped, then it would be y equals alpha x c1 cosine beta x plus c2 sine beta x. And in this, the alpha is just negative a divided by 2, and your beta is square root of 4b minus a squared over 2. So we look at this over here and we set it up as r squared plus ar plus b equals 0, and we compare it to this. We see that our a is 8 and our b is 16. Now we go ahead and we do a squared 64, and our 4b is also 64. And if you go ahead and you do the quadratic formula, so if you set this up with this, so it would just be r squared plus 8r plus 16 equals 0. Go ahead and do quadratic formula, so negative 8 plus minus square root of b squared minus 4a times c all over 2 times a. So you're going to get negative 8 plus minus 0 over 2. So negative 8 over 2, and you get a negative 4. And since the a squared is equal to 4b, it is critically damped. So you set it up in this form right here. So our final answer would be c1 plus c2 x e. And we got negative 4 for that root, so negative 4x. In this next problem, it says that the magnitude of the resultant of 3 coplanar vectors, a, b, and c, is most nearly. So coplanar vectors have to be on the same plane, coplane. And then collinear vectors would be on the same line. So this one, it's saying it is coplanar, a, b, and c. So you can look under statics section, page 72 of the reference handbook, and you'll find the equation that you need to solve this. Everything is given to us, so what we want to first do is write out Rx, which is the sum of the force. So this problem is resolution of a force. So that's what it's asking us. So to do that is the sum of the force xi, and then for ry it is the sum of the force yi, and here I we have ABC, so we can just label it as 1, 2, and 3. So to solve for Rx, it's really easy. We just put 2.15 plus, and so it's this reference to this, and then this reference to this. So 10 cosine, because this is on the x-axis, and it's a degree of 125. So doing that, we know it's 2.15. We go ahead and we use our trusty calculator to multiply 10 times cosine 125. Make sure you're in degrees. We get negative 0.74. Negative 5.74. We go ahead and do this, and we get negative 3.59 north, since these are all north. Then we do Ry, which is the same thing, 2.15 plus 10 with reference to that. And this time it's on the y plane, so it will be sine 125 degrees. So 2.15, and now we do 10 times sine of 125, and we get 8.19. And we get an answer of 10.34 north. And now, since the problem asks the magnitude, what do? We take take its magnitude of these two. So negative 3.59 squared plus 10.34 squared, and our final answer will be 10.95. So you look for the answer that is closest to that. In this problem, it asks which of the following is a unit vector perpendicular to the plane determined by the vector A and B. So to get perpendicular, we have to do the cross product of these two vectors. And how we set that up is we set it up in a matrices. So how we write it is we have three variables, I, j, k. Then we go ahead and we put the first one, their coefficients, so 2, -5, and 1. And then the next one, it is 1, -1, and 1. And the cross product of vectors A and B is, so for the first one, what you do is when you're doing this one, if you remember, you ignore the things underneath. So then you're working with these four right here. So for the first one is a positive, and you go ahead and you do -5 times 1, which is -5, and then you do -1 times 1. So this is the determinant, if you remember this from like linear algebra, -1 times 1. So it is -1. So the first one's positive, the next one is a negative. And then when you're doing this one, you ignore the line, these two right here. So you do this times this minus this times that. So 2 times 1, 2, minus 1 times 1, 1. Then you go back to plus. Okay. you ignore this. So 2 times negative 1 minus 2 minus negative 5 times 1 minus 5. So negative 5 plus 1, negative 4. So negative 4i. 2 minus 1 is 1. So minus j. And then negative 2 plus 5 is a positive 3. So plus 3k. So once you have this, what do? So getting a unit vector, we divide by the magnitude. So we did this in the previous problem. To get the magnitude a and b, we just take the square root, the coefficient negative 4 squared plus minus 1 squared plus 3 squared. We get that to be 16 plus 1 plus 9 square root of 26. And now to get our final answer, we just go ahead and we put this over the magnitude. So minus 4 minus j plus 3k over 26. Now obviously if you can reduce this, and if these have like 4, 2, 4 coefficients, and down here there's like a 2 square root 2, then you obviously divide it out. But since this one is not divisible, you just leave it like this.